Hello everyone. So today I'm going to take you through an experiment to show a really good example of a reversible reaction. Now the reason I'm doing this today with you is because in the webinar, whilst you were great at understanding what a reversible reaction was in theory, lots of you wanted to know what it looked like. And the best way I can show you this is experimentally. So as you can see, I'm in school, I'm going to take you through a practical, and hopefully by the end of this short video, you'll have a little bit of a better appreciation and understanding of what a reversible reaction is. So let's get started. So the first reagent we're going to use today is we're going to use some copper sulfate. Copper sulfate is a blue solid. It is a salt that you obtain by reacting copper with sulfuric acid. Now, copper sulfate reacts with heat and forms anhydrous copper sulfate and water. Now that means that it is an endothermic reaction. And hopefully you can remember what that means, but it means that you have to give energy to this compound so that it can absorb that energy in order to react. Okay, so we're going to heat this on a Bunsen burner in an evaporating basin and we're going to see what happens. So here is our practical setup. You can see that we've got our heat-proof mat and Bunsen burner. We have our tripod. Underneath our evaporating basin, we have a clay triangle. Now this just allows our Bunsen burner to sit and not move around too much. What we're then going to do is we're going to light the Bunsen burner after I have put in some copper sulfate into the evaporating basin. And we're going to heat gently and see what happens. So, as I've started heating this on the gentle flame, I'm just going to turn it onto the hot flame, which is where you open the collar on the Bunsen burner. And what you should be able to see, that this blue powder that we originally began with is now starting to turn white. And if I move some of this powder around, you hopefully will begin to again see we're starting to lose some of that blue colour. And what's happening here is in this endothermic reaction, when I heat this solution, this powder, I am causing the water that's bonded to it to leave, to break the bond with the copper sulfate and to evaporate. And so I am left with what we would call anhydrous copper sulfate. I will go through exactly what the products are of this at the end. I'm going to continue to heat this and then I'm going to let you see what it looks like at the end. So I've just stopped it there so that you can see the overall colour change. Now you might be looking at this thinking, that looks a bit gross. Well, there's a little bit of residue at the bottom here from something that was in the evaporating basin before. But what I want you to really focus on here is that this copper sulfate is no longer that beautiful bright blue colour that it started. By heating, I have caused a reaction to take place, and I can tell that a reaction has taken place because there has been a colour change. And as I said before, water has evaporated from this compound, leaving what we would call anhydrous copper sulfate, which basically means copper sulfate on its own. Now, what we can do now is begin to show that it is a reversible reaction. What I'm going to do is I'm going to grab some water. Now, remember, this reaction was an endothermic reaction where water was lost to the environment as a gas. Now, if I reintroduce water and I react anhydrous copper sulfate with water again, I'm going to cause the reaction to move in the backward direction to the left-hand side. Okay, and the reason that's going to happen is because I am causing these two things to react. Now, this is a beautiful bubbling solution of copper sulfate. And it's gone blue again because I have formed the compound that I began with, which is hydrated copper sulfate. Now, what we're going to do now is we're going to heat this up again to see if we can't make it go the other way. Compound again, and you'll notice that it's bubbling quite rapidly. So I'm just going to turn it down. I'm just going to put it back onto the slightly cooler flame. You can see that we're bubbling, and that's because the water that's in there is also evaporating. I added a little more water because I didn't want it to to evaporate dry. So as this continues, what we're going to see is that first of all, the water that I've mixed in with the solution that's just in excess is going to evaporate. And what we hopefully should see now, as this water begins to evaporate, is that that blue powder begins to turn white. And you can see that it's losing its really strong blue colour. Just turned it onto the safety flare there, guys. And you can see that we're starting again to produce this white anhydrous copper sulfate. And again, anhydrous copper sulfate is what you get when you heat hydrated copper sulfate. Now I'm just going to turn the Bunsen off. And again, I'm just going to mix it to show you that you have in fact made, oh, it's a bit stuck now, the anhydrous copper sulfate. So you've got your white powder being produced there. And to show that it wasn't a trick of the camera, when I introduce water again, you again are making hydrated copper sulfate. That blue compound is produced once again in the reaction. So, we've seen the experiment, but what actually was going on? Well, we know that when we heated the solution, we lost that blue colour, and we, instead of having a blue crystalline solid, we instead produce a white powder. And when we reintroduced water afterwards and we reacted the water with the anhydrous copper sulfate, what we saw is that that blue colour returned and we had formed a new compound. So let's look specifically at what we had. So we started with hydrated copper sulfate, and that is CuSO4.H2O. Now, you don't really need to understand what that dot means, but it's basically saying that the water is coordinated to the copper sulfate, and that means it's kind of bonded to it. Now, when we heated this reaction, when we heated this substance, we produced anhydrous copper sulfate, which, guys, is basically copper sulfate on its own. We also produced water, but this water was in the form of water vapour. So we can put a little G there to show that it was a gas, okay? And we know that it was a gas because it left the reaction vessel, it evaporated. Now, what I did though, is I was able to get back to my starting material. And my starting material was that lovely blue compound, remember? Now, because I not only could have the forward reaction producing the anhydrous copper sulfate and water, but I also could react water and anhydrous copper sulfate to make my starting material again. We say that this is a reversible reaction. And what you should be thinking is that there's something missing here. And what's missing is our reversible sign. And that's where we draw two half arrows going in opposite directions to show that these reactions can go either way. Now, what we can also say is that we know that this forward reaction, the reaction that runs to the right-hand side, well, that is an endothermic reaction. And we know it's endothermic because we had to heat it up to make it happen. So this is an endothermic reaction. Now, because the forward direction, this direction here, was endothermic, well, that means that the backward direction, going back to the left to our starting material, must be exothermic, okay? And that's true. It's hard for us to show that there because our reaction vessel was already quite hot. But as you mix the anhydrous copper sulfate and water, a very small amount of energy is released, okay? And that shows it's an exothermic reaction. And for what we're going to move on to, it's really important that we understand that if it's endothermic one way, it's exothermic the other way. So this was an example of a reversible reaction. Hopefully now you understand the theory behind it a little bit more. If you're still confused, please do email your teachers and rewatch the webinar and this video to help really cement it in your mind.